Okay, let's get into some story problems here, huh? Everybody loves story problems. New setup here. Okay. A pet store sells angelfish and clown loaches. Clown loaches is a type of fish. They sell 2 angelfish and 6 clown loaches. They collect a total of $36. If angelfish cost $2 more than clownfish, what was the cost for each type of fish? So these are the 2 answers. We're finding the cost of the angelfish and the cost of the clown loaches. Okay, if you had me for Algebra 1, you know what's coming here. But if you haven't, we've got 3 units here. Okay, angelfish, clownfish, and dollars. So making those 3 boxes in the table is not going to cut it. And the reason why that's not going to cut it is because there are 3 units now, 3 units of measurement in this problem. The angelfish, the clown loaches, and the dollars. So with 3 units, what I like to do is kind of design the old tic-tac-toe table. Okay, I've always got good results with this. Looks like that. Here's how you label the top. Together, you're always going to put the word together. Now, 2 of these are your independent units, the angelfish and the clown loaches, the 2 things we're spending money on. Angelfish, you can abbreviate if you want, but I'll be thorough, and clown loaches. Okay. Now, down here on the sides, here's how we label. How many units, I should say. That has nothing to do with money. And the next 2 have stuff to do with money. This is the money per unit. And this is the money total. Okay? If you set it up like that, you're good to go. Good to go. Now, money total. We know the total was $36, so there's going to be an equation down there that's equal to 36. Now let's come up to the top box. How many units? How many units of angelfish are we buying? Well, 2. Clown loaches we're buying 6. And then together 2 plus 6 would be 8. So there's no real equation up there. Okay, together we need to ditch that box. Now the cost per unit. The only thing we know about the cost per unit is that the angelfish cost $2 more than the clownfish. Now that doesn't mean either one of them actually cost $2. It just means the angelfish are cost $2 more. So with the angelfish I put plus 2. Now we still don't know what they cost, so this is going to be x plus 2, and this is going to be just x. Because these are both unknown, I just can write them both in terms of x because they're comparison. That's 2 more than this. Now here's what I do. So I bought 6 units of clown loaches and the price per unit is unknown. So we take 6 times x and that's 6x. Now right here we want to parenthesize that expression and I apply the distributive property. 2 times x and 2 times 2. Remember timesing. 2 times x is 2x, 2 times 2 is 4. So that's my expression for the money total for the angelfish, and then 6x is the clown loaches. So now I have my equation. It's an easy equation to solve. Okay, so I combine my x's. It's going to be 8x plus 4 equals 36. And I subtract 4 from each side. 8x equals 32. Divide by 8, and x equals 4. Okay? So these 2 unknowns, I now know that x is 4. So the clown loaches, the cost per unit is $4, and the angelfish, 4 plus 2 is $6. Okay. Okay, next one. An adult pass for a county fair costs $2 more than a children's pass. When 378 adult and 214 children's passes were sold, the total revenue is $2,384. Find the cost of an adult pass and the cost of a children's pass. So I want to find out how much the adult passes cost and how much the children's passes cost. So if I get decimals for the answers, that's fine because I'm finding cost. So again, you're dealing with 3 units of measurement, the number of adult passes and number, and you're like, well, those aren't units of measurement. Yeah, but in the world of algebra, they are, okay? Adult passes, children's passes, and dollars, those are all money quantities in this problem. So together, and then we got the adult passes, and the children's passes. Those are your two independent units up here, and then they're being bought together. Then how many units do we have? Money, money, this is money per unit, and this is money total. Okay. So how many units of, okay, first off our total, we know that that's $2,384. Okay, how many units? Well, there's 378 adult, and there's 214 children. So 378 plus 214 is 592. Okay, like on the last problem, the only thing I know about the cost per unit is that an adult pass costs $2 more than a children's pass. So that doesn't mean either one of, you know, it doesn't mean just put a 2 in one of them, okay? It means you put plus 2 with adult. These are still unknown, but I can write them both in terms of x, okay? X and x. 214 times x is 214x. Then I parenthesize and distribute. So 378 times x is 378x plus 378 times 2 is going to be 756. So I now have an equation, okay? So 378x plus 756 plus 214x equals 2,384. So I combine the like terms of x, that's going to be 592x plus the 756, that's a constant, equals 2,384. Then I subtract 756, that's going to be 1,628. And I divide by 592, and x is 2.75. So I go on my table and just replace those x's with the solution for x, 2.75. So the adult passes, 275 plus 2 is 475, and then the children are just 275. Okay. Third example, at a play, $2,995 was collected from tickets. Adult tickets cost $2 more than student tickets. If 325 children and 404 adults attended the play, find the cost of each type of tickets. You got adults, you want to find out what the cost is per ticket, and the students, trying to find the cost per ticket. So again, that's 3 units of measurement. 3 units of measurement, we're rolling with this. So together, this is kind of like the last problem. We're buying adult tickets. You can abbreviate your stuff as long as you know what it represents. Just a means to an end. Then how many? And then dollars per unit and total. Okay, so together the total cost is going to be $2,995. So that's the total cost together. Now how many units? Oops, I forgot how many units. So that means how many adult tickets? 404. The children were 325. One thing, if you struggle to read like story problems, like I'm not ripping you, I'm not saying this in a snide way, trust me. One thing, this column here is not about the money. So you're kind of in this column, these are for values given to me in the problem that are not cost related. So it'd be the 325 children, the 404 adults. Okay, so I add those, it's going to be 729. I don't really do anything with the 729. I just like to fill out all my information. Okay, we know the adult tickets cost $2 more. Okay, so adult tickets is plus 2. X plus 2 and X. So 325 times X is 325X. Because if you had to find the cost total for student tickets, you'd take how many units times the cost. But we don't know the cost, so we write the expression 325X. Now here I'm multiplying by 2 terms, so I apply the distributive property. So 404 times X is 404X, and then 404 times 2 is 808. So my equation is 404X plus 808 plus 325X equals 2,995. Okay, combine the X's, that's 729X plus 808 equals 2,995. Then I subtract the 808 from both sides. 729x. 2,995 minus 808, I think it's 2,187. Go with that. Hopefully I get a decent answer. And then this divided by this gives you 3. Okay? So those unknown x's we know are 3. So the adults, 3 plus 2 is 5. So those cost $5 and the student tickets cost $3. Okay, last example, and then you can work on the part 1 of your assignment. Hardcover books cost $3.50 more than paperbacks. $198 was collected from selling 20 hardcover books and 12 paperback books. Find how much each type of book costs. So I want to find the cost of a hardcover book and the cost of a paperback book with the information provided. Okay, so again, that's 3 different units, okay, so together. You split them into 3 because the hardcovers and paperbacks are bought together. They cost different amounts. So these are your hardcover, paperbacks. How many units? And then money. This is the cost per unit, and this is the total cost. Okay, total cost is $2,995. Okay, so how many units of hardcover books are we buying? We're buying 20, and then we're buying 12 paperbacks. So 20 plus 12 is 32. Now, we do know about the cost per unit. One thing about the cost per unit, the fact that the hardcover books cost $3 more than the paperback. So I put plus 3.50, but now I can at least, they're both still unknown, but now I can write them both in terms of x. So 12 times x, 12x. Here I apply the distributive property. 20 times x is 20x. 20 times 3.50 is 70. Okay, so now I have my equation. 20x plus 70 plus 12x equals 2,995. Now combine your x's, that's 32x plus 70 equals 2,995. So I subtract 70. Guys, I screwed up. The total's not $29.95. That's from the last problem. I read the wrong thing. It's $198. I'm sorry. Okay. $198 minus 70 is $128. Okay. Then I divide by 32, and x equals 4. Okay. Okay, so x is 4, so 4 plus $3.50 is $7.50, and then 4. Okay, pause the video and do those 2 problems, and then resume the video. Okay, next. A student sells small and large greeting cards. The small cards cost $3 each, the large cards cost $5 each. The student sells 25 cards, they make a total of $95. How many of each type of card were sold? So small and large, but not what they cost, actually how many of them there are. Now again, 3 units because you're buying the small cards and the large cards for money, okay? I forgot to put money in, oh no I didn't, okay? So again, that's the good setup, but the table is going to look different than what we did on the previous page. Vastly different, okay? Because we're buying small and large. How many units, money, per, and total. Now the total cost we know is $95, okay? So there's going to be an equation down there. Now there's going to be another equation too, so it's going to look vastly different, the information in the previous table. So how many units? The only thing, I don't know how many units of small, I don't know how many units of large. Really the only number of units I have is the 25 cards, but since it doesn't say small or large, that's together. There's going to be an equation here. This is x, this is y, because those are going to be the answers. Okay, get rid of that. Now this time we do know what the cost per unit is. For the smalls, those cost $3 per unit, and the large, those are $5. So that's going to be 3x, and that's going to be 5y. So there's two equations. So I like to make 4 boxes and just work the system. I know that x plus y equals 12, or 25, 12. Why am I saying that? Then I know 3x plus 5y equals 95, okay? Now we're going to use elimination because the x's and y's are lined up, so are the constants on the other side, okay? So I need to multiply this equation by 3. This equation could be multiplied by 1, which means it's staying the same. So now the top equation is 3x plus 3y equals 75, and the bottom is 3x plus 5y equals 95, okay? Now you need the 3x's to be 1 positive, 1 negative. So negative, and then 5's negative, and 95's negative. So I add. 3 and negative 5 makes negative 2y. 75 added to negative 95 is negative 20. Then I divide by negative 2, and y equals 10. Now go up to your y, so you know there's 10 large. Now dude, you can plug 10 into the equation there, but a quicker way to solve these is just to say, okay, what plus 10 gives you 25? Well, 25 minus 10 is 15, okay? So x is 15. I mean, you could put in 10, but you're kind of wasting time. Okay, next problem. You buy apples and oranges. The apples cost $2 per pound. The oranges cost $2.25 per pound. You bought 25 pounds of fruit. The total cost is $52.25. How many pounds of apples and how many pounds of oranges did you buy? So pounds of apples and pounds of oranges. Okay, so together, you get your apples and the oranges. Okay, how many units? How many units in this problem would mean how many pounds there are? And then money per unit and total. So the money total is given to us, it's $52.25. Then how many units? Okay, we know the only units we're given is 25 pounds, but that's of fruit, so it doesn't specify apples or oranges, so I assume that would be together. Okay, that's going to be x plus y. So the cost per unit of apples would be $2 per pound, and then 2.25 for the oranges. So x multiplied, so that would be a 2x, and that the total for the cost for the oranges would be expressed as 2.25y. So we have two equations, okay? So we need to create a system out of it. Because we know the unknown x plus the unknown y equals 25, and then 2 times the unknown x plus 2.25 times the unknown y equals 52.25. Okay, then I multiply by 2, and then by 1. So it gives us 2x plus 2y equals 50. And then 2x plus 2.25y equals 52.25. Okay, we want to add these, but we need a positive and a negative 2 to get rid of the x's. And negative. 2 and negative 2.25 is negative 0.25y. You're always plussing them. Use your calculator if you have to. Don't write 102.25, that's wrong, because the 52.25 is negative. So 50 plus negative 52.25 is negative 2.25. Then I'm dividing each side by negative 0.25, and that gives me my y solution. These aren't hard to do really, you just have to be careful with your negatives. You can't overlook them. 9. Okay, so y is 9, so 9 pounds of oranges, and then to find the pounds of apples, we can just take 25 minus 9 is 16. because 16 plus 9 is 25. Okay, at a football game, student tickets cost $3 each. The adult tickets cost $5 each. The school sold 700 tickets. They made a total of $3,078. How many adult tickets? How many student tickets were sold? So adult tickets and student tickets. So I got adult tickets, student tickets bought together at a price. So that's 3 units of measurement that are important in this problem. The 2 independent units are the adult tickets, because cost is always dependent on your units. So what are you buying with your money? You're buying the adult tickets and the student tickets. So how many units per unit? Cost, and the total cost. Okay, total cost in this problem is $3,078. Okay, how many units? Well, the only thing we know about how many units is 700 tickets, and that doesn't specify students or adults, so I assume it's the total. And then x plus y equals 700. Okay, adult tickets cost $5 each, and the student tickets are $3 each. So I express the total cost for adult tickets as 5x, y times 3 is 3y. So again, it's another system. X plus y equals 700, and then 5x plus 3y equals 3,078. Okay, then I apply elimination. Okay, so times 5 times 5 times 5, and then 1, 1, 1. So that's 5x plus 5y. 700 times 5 is 3,500. Then on the bottom will just remain the same. Okay, I would like my 5x's to cancel, so negative 3, negative 378. Now we add 5 and negative 3 add to 2y. 3,500 and negative 378 make 422. Remember, if you end up with 6,578, it's because you're not making that negative. You're ignoring the negative. You can't do that. Okay. So y is 211. Okay, student tickets, 211 of those. The adult tickets, we need to take 700 minus 211, and that's 489. Okay, so now I know the unknowns. I know everything about this problem. Okay, final problem. A farmer's market is selling apples for $1.99 per pound and oranges for $1.50 per pound. You buy 12 pounds of fruit. You spend a total of $21.92. How many pounds of apples, how many pounds of oranges did you buy? So pounds of apples and pounds of oranges. Kind of similar to a problem I just did. So apples, oranges, and then they're being purchased together. So how many units? Money per unit and total. Alright, so the total cost together is $21.92. Okay, how many? The only thing I know about the number of units is 12 pounds of fruit. So 12, that's x plus y equals 12. Cost per unit, the apples are $1.99 per unit, and then $1.50 per unit for the oranges. So that's going to be $1.99 x, and then $1.50 y. Okay, so x plus y equals 12. That's my first equation. And then $1.99 x plus $1.50 y equals $21.92. Alright, so 1 and 1. Again, I'm using elimination because the x's and y's are lined up. So I multiply the top by $1.99. Remember to multiply your 12 by $1.99. I have a lot of people who will just leave that at 12. No, you got to multiply everything. Bottom one or just remains constant. Okay, So 1x times $1.99, $1.99x plus $1.99y. Please do not put equals 12. We also need to multiply our 12 by $1.99. $23.88. Bottom remains the same. $1.99x plus $1.50y equals 21.92. Okay, I want to add, but for that to work out, we need opposites on the x. But then we got to make the 150 negative and the 2192 negative. So $1.99 plus negative 150 is 0.49y. $23.88 plus negative, remember the negative, you don't put the negative, the answer is going to be wrong because you'll get something too high. $1.96. Then I'm dividing both sides by 49 cents, 0.49. And that's 4. So I bought 4 pounds of oranges. And then 12 minus 4 is 8. So it'll be 8 pounds of apples. Okay? And you got 2 problems there.